All right. Why do you bring peanut butter on road trips? For the traffic jam. All right. So, last one of the topic. We touched on this more in year 12, but this is an introduction that you get in year 11, and it's a good one to know, especially for your prelims. Okay. Now we're talking about exponential rates. That is the big keyword here. Keyword is rates. Okay. Now I'm going to play a bit of a game. Every time I say rate of change, what are we going to do? We're going to differentiate. And only when I say rate of change. Okay, so if it's not rate of change, you don't differentiate. If it's rate of change, what do? Differentiate. All right, so I'm going to give this very standard type question. Exponentials is normally used for a lot of exponential growth or decay. One good example is population. Sometimes it grows, sometimes it shrinks. I'm just going to say for this particular question, population is modeled by P equals 1,000, e to the 0.2 t. And t is, I guess, time in years, and P just represents the population. Okay, a lot of this type is going to be understanding the language. Okay, now if it says find the initial population, I want you to tell me what's the time initially. That means at the beginning. How much time has passed? Boom, none. Okay, 0 time has passed. So whenever you see this phrase initial, and of course we're talking about population, have I seen rate of change yet? No, not yet. So I'm not going to differentiate. I'm just going to sub t equals 0. So population is going to be 1,000 e times 0.2 times 0. That just becomes 1,000 times e to the 0. Anything to the power of 0 is 1. So this just becomes 1,000. So what's my population? What's my initial population? 1,000. So far, so good. I hope so. All right, because I'm a bit pedantic, I'm just going to write P equals. Okay. Now, find population after 3 years. Again, let's play a game. Have we seen rate of change yet? Nope. So do I need to differentiate? Nope. So in this case here, population after 3 years. Okay, so that means T is going to equal, my time is going to equal to 3. So let's sub it in. Just from before, I'm using the same equation as I did up here. P is supposed to equal to 1,000 e to the 0.2. And instead of timesing it by T, I'm going to let T equal to 3. Put that in the calculator. Haven't done this yet. 1,000 times e to the power of 0.2 times 3. That'll give you, my population is now 1822.11. So theoretically, it's just going to be 1822 if it's to the nearest person. Or nearest whole, or whatever you want to call it. Okay, next question. Find population rate of change at 3 years. What are we going to do? You should have seen it. Rate of change, which means we're going to differentiate. Now, just remember, P equals to 1,000 e to the 0.2 t. Okay, now when I differentiate, I can call it P dash, or to be more specific, or what you'll see more often is I'm differentiating P, and in this case, it's not going to be respect to X, it's going to be respect to T. Okay, so hopefully you remember what's the rule. Okay, differentiation of your power comes down the front. So in this case, it'll be 0.2 comes down the front, and then I'll multiply this by the original 1,000 times e to the 0.2 t. And so sometimes they'll say, okay, that's 0.2 p, because what is this? This is exactly the same thing as p. Okay, but for this particular case, let's just kind of work with this. So I've got 0.2 times 1,000, that's 200. So that means my rate of change now is 200 times e to the 0.2. Yep, then I guess I sub in 3 because it's after 3 years. And now this becomes 200 times e, oops, e, I'll try again, e, oh my goodness, times pi, okay, times e to the power of 0.2 times 3. That becomes 0.6. And what I've ended up with is 364.4. Now remember, this is a rate of change, which means this is talking about it's going to be whatever many people per t, which is time, it's going to be per year. Okay, so essentially, because we're talking about people rounding to the nearest person, I'll just say 364 people per year. Okay, so remember, rate of change means we do what? We differentiate. Okay, now average rate of change over 3 years. Now, this one here, it says average first of all, and then it says over, not at the 3-year mark, but it says over the 3 years. This tells me that I kind of need to do, it's kind of like finding the gradient. We use this rise over run. Okay. So what I need to do is, it's going to be y2 minus y1 on x2 minus x1. Or in this particular case, it's going to be my population at 3 years, take away my initial population over, I guess, the time, which is 3 years, take away 0. So I've got all the information already. What's my population at 3 years? I think I said 1822. What's my original initial population? It was 1,000. That was all the way from question 1, initial population. And yeah, 3 take away 0, that's that. And so my average rate of change is just going to be, put that in the calculator, approximately 274 people per year. So that's my average. My average means I always use 2 points. Okay. And just to touch base, looking at this one here, because this one was talking about at, this one's kind of talking more about a tangent, whereas this one here is talking more about a chord. Okay, hopefully that rings a bell from when we worked on some calculus a couple topics ago. If it doesn't make sense, leave a comment. All right, now this one here is probably the big boy question. Now it says here, find the rate of change. Ooh. So what does that mean? I'm going to need to use the derivative of the population when. So I'm just going to highlight some of the keywords here. Population is P, right? Oh, whoops. Yes, of course, population means P, but probably this population here is the one that means P, right? 2718. Now, when means I'm solving, I'm looking for a time. So in other words, I'm solving for T. Okay, so I'm trying to find the rate of change of the population when the population hits 2718. So let's break this down. I want my population, which is given by 1,000 e to the 0.2t. I want that to equal to 2718. Okay, now the easiest way to go about this is, guess what? Because I wanted to know when, I need to solve for my time t. And this is where kind of like all your log laws kind of come in, or all your solving for exponentials and logs become handy. Bear with me here. I've got e to the 0.2t. First thing I'm going to do is I'm going to divide both of these by 1,000. Okay, now getting closer, I'm just going to see if there's a nice number for that. 2718 divided by 1,000. Oh, it's horrible. 1359 over 500. So much for a great thing. Now, what I'm going to do is, do I have room? Yes, I do. I'm trying to solve for t. I can't do that until it's not a power anymore. So what am I going to apply? I'm going to apply a log. Okay, so that means log of my base, which is e. Can you see that? There's my base, using a log of my numeral, which in this particular case is this guy, 1359 over 500 should equal to my power, which is 0.2t. Okay, so I've just used the log. This is completely fine. And what I'm going to do now is I don't want 0.2t, I just want t. So I'm going to divide both sides by, and this is where it gets a little bit gross. I want to divide it by 0.2. And that there is going to help me solve my time. And I'm hoping that if I put this in the calculator, remember I'm using ln. So ln of 1359 over 500. And you should be doing this in your calculator too with me, just to make sure that it's like all G. And then put it over 0.2. What you'll find here is t becomes 4.999, blah, blah, blah. And so essentially, it's when t equals to 5. Okay, so now looking at this, I now know when the population hits 2718. Okay, I know exactly when. It happens when time equals 5 years. But what they're asking me for is they're asking me to find the rate of change. And essentially what they're asking for is they're asking me for the rate of change, dp dt, at the particular point when t equals to 5. So again, dp dt, I think we figured it out from before. It was 0.2 times 1000. Oh, we found out it was 200, I think. Going from before, 200 e to the 0.2 t. And so at t equals 5, all we need to do is sub it in, 2000 e to the 0.2 times 5. And that becomes 2000 times e to the power of 0.2 times 5. Let's see if I can fix that. 0.2 times 5. It should become 5436. Oh, not 2000. Sorry, guys. 200. That's going to change it significantly. It becomes 543.6. And so I'm going to say approximately 544. And because it's asking for a rate of change, again, rate of change means it's going to be a rate, people per year. So that means, again, let me try and make sense of this. When the population hits 2718, I'm going up by, that means my rate of change is I'm growing by 544 people per year at that point. Okay, might be a lot to wrap your head around, but watch this video over a couple times until you can start to understand what I'm saying. I'm going through this quick because it's a video. You can pause, replay, watch it again. But yeah, that is what you're looking at. All the best for your exercise and good luck. Alrighty, bye.